Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about hexachloroacetone. So as usual student, I first request you please read the question carefully. What reactant is given, what reagents are given, and what is asked, what is the major product of this reaction. And here you can see 4 options are provided and one of them is the right answer. Now, so I believe that student, it is better for you if you pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. This is because self-evaluation is essential for improvement, and that's why you should try. Now, I believe you have tried by yourself. It's my turn to give you the right answer. So if you look this reagent a little carefully, student, this is hexachloroacetone. It's a pretty interesting molecule. So you can see all hydrogens of acetone are replaced by 3 chlorine atoms. And from these we can conclude one thing, that this carbonyl carbon is significantly electrophilic. Why? Because the CCl3 group has a strong minus I effect. So which makes this carbon more delta positive. Okay, means electrophilic. Obviously you can say that it has a bulkness factor too, because CCl3 group is significantly bigger, but overall it's reactive. And this concept is this phenomena is governed by a concept named Burji-Dunich trajectory or Barge-Dunich trajectory. I have already discussed or dedicated lecture on it. You may visit for better understanding. Not only that, such kind of molecule, this hexachloroacetone, is a very good substrate for haloform reaction. So if you want, you may visit those lectures. Now I have already made. Now in this case, what I have taken this carbonyl, and here there is one reagent in HCl and pyridine. So simple student, anything HCl salt is taken and pyridine is taken additionally, then what will happen? Pyridine will react with HCl and it will neutralize HCl by formation of pyridinium chloride. So here pyridine is acting as a base, fine. But what is the reagent? This reagent is, student, actually this is OMe, this is NMe, and this is NH. So you can consider this reagent as an analogous of hydroxylamine, and this hydroxylamine is significantly high nucleophilic as well as reactive because of these adjacent atom lone pair repulsion, and this is called, student, alpha effect. So this alpha effect makes hydroxylamine as well as its derivative more nucleophilic, and nucleophilic attack happens from nitrogen side because compared to oxygen, nitrogen is a better nucleophile, and not only that, it has a proton which could be released after the nucleophilic attack to get the neutralization. So we understand that first step is the nucleophilic attack of these nitrogen to this carbonyl carbon. Okay, so let's see the mechanism stepwise. So first step is these lone pair will attack here. It will open up and this CCl3 will leave. This reaction is nothing but acyl nucleophilic substitution, and I have already made dedicated lecture on it. You may visit for better understanding. Now this part we understand, and second, of this proton will be abstracted by this pyridine which is present in the reaction medium as base. So first step, it will produce an amide, and such kind of amide has a special name that is called Wenrev amide. I shall make a dedicated lecture on this very soon. Now, but question, reaction will not stop here because other side is also similar, and that's why again the same course of reaction will happen. It will come back and this CCl3 will leave and produce this amide of, you can see, carbonic acid. Okay, so here these two came from the reagent part, and these C double bond O came from the reactant, means this hexachloroacetone part. Now a question, in this case, why the acyl nucleophilic substitution or CCl3 elimination is preferred where nucleophilic substitution on CCl bond? Because we have studied one phenomena, student, that alpha halocarbonyl is very good substrate for SN2, it's true, but in this case student, this nucleophilic substitution is actually, this nucleophilic attack is favored because the what is the leaving group here? Leaving group is CCl3 minus carbon ion, and this carbon ion is resonance stabilized because of, first of all, minus I effect of this 3 chlorine as well as minus R. Now we will say that, sir, how minus R type, I will not say minus R type withdrawing works. Actually student, this chlorine has energetically accessible vacant d orbital, and that is capable to overlap with the negative charge present in the p orbital, and that's how it could be stabilized. So that is a very interesting phenomena which chlorine can do. So that's why CCl3 minus leaves. Not only that, if you look at this Reimer-Tiemann reaction, I've already made dedicated lecture on it. In that reaction, first this chloroform react with base like sodium hydroxide or potassium hydroxide and produce CCl3 minus, which subsequently undergo chloride elimination to produce that dichlorocarbene. So every case this CCl3 minus is produced because it is relatively stable. Now this much we understand, and in the next step what will happen after this amide preparation? It reacts with phenyl lithium. So this phenyl lithium act as nucleophile and it attacks, so I'll say that it attacks this carbonyl group, okay, and ultimately it opens up, later on it come back and this part leaves, and since both sides are symmetrical, means both side amide, so both will leave and ultimately it will produce this diphenyl ketone derivative. Now this chemistry is called Wenrev amide chemistry. So it's a very interesting for carbonyl compound preparation. So if we look at the key steps and the name reaction associated here, the first step is acyl nucleophilic substitution, and these hydroxylamine derivative is activated because of alpha effect, so it's act as nucleophile. So 2 substitution happens because 2 CCl3 are there, and the last step is associated with ketone preparation using Wenrev amide. So this is the Wenrev amide is produced after this, and these Wenrev amide is used for ketone preparation. Okay, now interesting part is that since we have taken these hexachloroacetone and CCl3 left, so only the carbonyl part came from this hexachloroacetone, and symmetrical ketone we made, means this 2 phenyl came from these organolithium reagent. So that is the uniqueness, as well as actually student, it's a selective reagent because these reaction stops at the ketone stage at minus 78 degrees centigrade, because the intermediate is stabilized, okay, through chelation, means this oxygen is responsible for this chelation. Now, so what is the answer here, student? Answer is diphenyl ketone. This is. Now question is, if the question is asked in your exam less than 30 seconds, how can you come to the right answer? Very easy way. So first of all, you need to understand about this reagent first. So HCl pyridine, it's a neutralization reaction and it will produce this hydroxylamine derivative, and nitrogen is more nucleophilic in hydroxylamine. So it will attack, and since this CCl3, 2 CCl3 can leave, and look at excess reagent is given. So 2 substitution will occur. So obviously this is not possible. Gone. Fine. Now another thing, so this reaction is not possible even if I say that it will act as nucleophile. So this CCl3 minus will leave. How phenyl lithium can react with CCl3? Option A is also gone. So competition between option C and option D. Now in this context, one name reaction you should know, that is Wenrev amide preparation, and these reaction is selective at low temperature like minus 78 degrees centigrade. What do I mean by the statement? At this lower temperature, the nucleophilic addact, means addact produced by this nucleophilic attack, is stabilized by the chelation with the hydroxylamine derivative. Okay, that's why this C is the product. So this D is not possible here. So now question is, carbonyl carbon can attack, in this carbonyl carbon can act as electrophile, and actually it's electrophilic in nature, and in this context aldehyde is better electrophile than ketone, because carbonyl carbon is electrophilic, fine, but aldehyde is associated with less bulkness compared to ketone. So that's why both steric and electronic factor control this, and this is governed by the concept Bourguignon trajectory. Now electron withdrawing group CCl3 attachment with carbon makes it more electrophilic. Now hydroxylamine is more, sorry, not electrophilic, it should be nucleophilic. So hydroxylamine is more nucleophilic due to alpha effect, means adjacent lone pair repulsion. I mean nitrogen lone pair and oxygen lone pair repulsion. And in this context, you should know that Wenreb amide is a very good synthetic intermediate for ketone or aldehyde, whatever, ketone preparation using Grignard reagent or organization reagent as nucleophile. But instead of this nucleophile, if we used hydride as nucleophile, then aldehyde is produced. Now this is due to the stabilization of the intermediate produced by the after the nucleophilic attack at that temperature. That's why this reaction stops at this phase selectively, and hexachloroacetone results symmetrically substituted ketone by Wenreb method. Okay, so this is the end of discussion. I believe this video will be useful. Thanks for watching, and if you really consider the content of my channel is worthy, then please help this channel to grow. So stay happy, stay blessed.